Where are you looking? Yeah, exactly, right here. You're looking there. So root 3 over 2, what triangle has the root 3 over 2? 30, 60, 90. So that means your theta is here. You're looking at the root 3 and your hypotenuse is 2. What angle looks at the root 3? 60. So in this case here, this would be my pi over 6. Oh, I'm sorry, pi over 3 or 60 degrees. You okay with that? Now, if I got rid of the idea of what you did yesterday about just quickly looking at that first position, what other angle has the sine value that's equal to root 3 over 2? In essence, what I'm asking, where else is sine positive? The second quadrant, which means that there has to be a reference angle placed here, up 60, so that means this is at 120, otherwise known as 2 pi over 3. So those two angles would have the sine value of root 3 over 2. Are we okay with that? Now, if I continue to, that's what I'm putting this at as, if I go one time around the circle, if I'm restricting myself to one spinorama jamma, if I'm looking at just going one time around, those are the two angles that give me the sine value of root 3 over 2. If I continually went around and around and around, I'd have to keep adding stuff to it, but I'm not doing that because that gets goofy. All right. Tangent -1. What angle has a tangent -1? Again, what you want to think of is what angle gives you ones for tangent. Remember, tangent's what over what?
Opposite over adjacent.
So in order to be 1, that means your opposite and adjacent has to be the same. So what we did yesterday, that meant that it was a 45 degree here. It was down 1, right 1. So it meant in our purpose yesterday, this was the tangent of -1 was at negative pi over 4 or negative 45 degrees. Okay with that? Now, if I place that in between 0 and 360, what would that angle be if it was between 0 and 360? Yeah, 7 pi over 4. Thank you for going right to radians. But I'm trying to make it easy on everybody. If it was degrees, it would have been at 315. You okay with that? The terminal side would have placed me to 315. I'm just getting you in the mindset is that you're still going to look for it, but then figure out where it is within a revolution. Yeah.
Something that I forgot to ask you from the homework group a few days ago when we were doing the reference angle stuff is when you have like a negative, and then like when they give you like a negative degree or a negative radian and you have to like draw it out and then do like the reference or like however it is to the x-axis.
Yeah.
Are we like when we rewrite it, would you want us to like rewrite it as like the negative 90?
Your reference angles are always going to be positive. I'm sorry, not reference angle, excuse me. The angle that you find will always be a positive angle. So even if your negative angle was negative 3 pi over 4, and you wanted to find the reference angle of negative 3 pi over 4, that tells me that you went this direction here, and your reference would have been 45 degrees off. You okay with that? Now, when you do that, that means the real angle that has the terminal side in the third quadrant would be coming this way, and it would have been at 5 pi over 4. Does that make sense? Because once you find the negative just tells you that the first thing is the direction that you're going to go. And then when you do everything else as you label out the angles, you're going to always think of it as this angle has a terminal position, find it from 0 and just bounce it back. And that gives you the real angle. Okay? Does that make sense?
Yeah, I think we totally. I was just thinking.
I think that's what you're asking me.
I think I'm getting the different concepts mixed up maybe, because I don't have all my homework in front of me, but I know that maybe it was when we were doing the sign, like, I don't know what we were doing in person. So maybe it was even yesterday.
We'll figure it out. We'll figure it out.
Okay, I'll
all right, we'll
ask
figure it out.
next time I come.
That's fine.
across it.
That's fine. No worries. So this has been our best friend in the whole wide world as of right now. But we've also realized that we don't need to know the whole thing, right? What do we need to know? We need to know that it goes cosine sine for your x and y, and tangent is always y over x. We know all of that. We know that your unit circle is built out of basically 3 angles. And we know how to find those 3 angles just by drawing the 2 separate triangles. We can do that all day long, and that has not been an issue for any of us that I've noticed without too much of a hassle. Aside from maybe tweaking a sign, SIG in here or there, but other than that, I think it's been pretty, you're not yelling at me and crying or anything, so we've been all right. I joke. But then the other thing that I want you to remind you of is this. All students take calculus. Where are your trig functions positive? Everything's positive in quadrant 1, sine's positive in quadrant 2, tangent's in quadrant 3, and cosine is quadrant 4. Or if you just remember ordered pairs, plus, plus, minus, plus, minus, minus, plus, minus. Works the exact same way, okay? Because what we do today is that we take what we were working on yesterday with that inverse stuff, but we back it up 2 steps. And we're gonna write out an equation with a trig function thrown in it. So you're gonna get everything to solve for x like you would have been able to on a calculator, but you're gonna do it where today, yes, it's just gonna be placed in a unit circle, and you'll be able to do that by hand, all right? For example, if we have solve 2 times the sine of x minus 1 equals 0. And what we're going to do is we're going to solve, not for what's called a general solution today. We're going to find all solutions. Find all x where x is between 0, and 360. And I think they use not included, included. I think they go that way. Let me double check real quick. General solutions are a little bit different, and I think I'll worry about that come Monday. But I want to just start with find all solutions today. They write it like that. Nope, I have it backwards. They have it between 0 and 2 pi. Including 0, excluding 2 pi. So in your mind, you're setting up what works out to be a 3-step equation, really. What do you do first to move something? Add the 1, yeah. So you have 2 sine x equals 1. Now that just means 2 times sine, which means what do you do? 2 to 5. What's that? And now, how do you undo a sine? You inverse. What angle has the sine of a half?
So then it's just like what we think.
Exactly. All we've done is we've backed it up to an equation to get me to what you did yesterday. We just backed you up, all right? So if I do that, 1/2, is that gonna be my 30/60 or is it gonna be my 45 triangle? 30/60. So it's gonna be my 30/60. And if I'm looking at a 1, that's my 2, that means that has to be my 30, so it's gonna be my pi over 6. Okay? Are we all right with that? So my value of that's gonna be at pi over 6, comma, where else in the unit circle is sine positive? Second quadrant, which means you have a reference angle of 30 degrees or pi over 6. So to come over to here, you are at exactly, and that's your answer. Find the values of x that create that as a true statement within one revolution. There's two angles that'll give you the sine. The sine of 30 and the sine of 150 will both equal a half. Yep. Yep, it's the same thing. Exact same thing. Sometimes you'll have multiple angles, sometimes you won't. It depends. In this case, I'm just looking for positives. Eventually, we'll look for plus and minus because you can take square roots. There's a lot, all right? Not bad, was it? Okay. Try that. Sorry, I didn't know if that was your one. Sorry. So if I have 4 times the cosine of x plus 1 equals negative 1. So it's a
0, 4 cosine x equals, oh, -2.
So once we remember that the opposite of adding is subtracting, we get 4 cosine,
Hopefully you remember that.
yeah, hopefully, is -2. Divided out, we get cosine of x is -1/2. Is it okay if I simplify that fraction right away?
Yeah.
Okay. Okay. What angle has a cosine of -1/2? Once again, you just write it out. Your angle is the cosine.
It's a 30, 60, 90.
It's going to be a 30, 60, 90. So you are looking at, it's negative. So cosine is negative in the second quadrant, which meant that my -1 is here. So I'm looking at a √3. That means it's a 60. So it's going to be a 2 pi over 3. Yeah, Trap.
Wait, so that's 120 degrees.
Yeah.
Oh.
Yep. And then where else is cosine negative? Cosine's negative here as well. So you add another, so this
I
would
thought
be,
cosine was just on the top 2 quadrants.
but we're looking at it, find all the angles within one revolution.
One revolution, like one full circle.
Yeah. Yeah. And you're right. It would be, if this is, remember this is 2 pi over 3, 3 pi over 3, 4 pi over 3. And there's your answers. Now, if it gives you your, in this case, we started out, I was looking for everything between 0 and 2 pi. That means that it's asking for your answers to be within radians. If it asks you between 0 and 360, it's asking for degrees. Pretty simple. A lot of times I might ask for both, but generally I like radians because they're rad. Why do you hate me so much? I'm so nice to you. You shake your head in dismay. I mean, I try to say something funny to you in the hallway, and you're like, ugh. Yes, you're just crazy. Oh no, there's a square root. I am afraid. I don't know what to do. Please, help me. Only one, you're my only hope. Blue spellers on the head. You know that scene where Illinois Nazis, I hate Illinois Nazis? That was a real thing that happened. It was. Yeah. There was a standoff at Skokie back in.
Oh, wait, yeah, I know something about that.
Yep, it was a real thing. I grew up in the city, and when they were filming that, my parents would take us to go watch them film it. So, just tells you that. That's okay. So you have √3 tangent of x minus 1 is 0. First thing you do is add 1. So we have √3 tangent x is 1. So that means the tangent of x is 1 over √3. Issue.
The opposite of, oh wait, I drew that where the 90-degree angle is.
Now, when I'm solving these angles out, when I'm trying to solve for these things, here's a little top tip. Don't rationalize. don't rationalize, because you're asking what angle has a tangent value of 1 over root 3, which means your opposite is the 1, your adjacent is the root 3. It's y over x. By doing it that way, by non-rationalizing your denominator sometimes, it's quicker to solve. It depends on the style of problem. In this case, it's really fast, and you're saying it's what? 30. Because at pi over 6, you're looking at at your 1. Next to you is your root 3. Now, if I wrote it out as root 3 over 3, yeah, but then I'd have to say, okay, if it's root 3 over 3, that means it had to have been a rationalized 1 over root 3. It's just taking less stress off of your brain. Generally speaking, that helps. Okay? So tangent of 30, or in this case, it'll be at pi over 6. Where else is tangent positive? The third quadrant. Now, if you guys remember this, third quadrant, isn't that just pi away?
It's just 180 degrees.
It's 180 degrees away from that, isn't it? So if I add pi to pi over 6, what do you get? Exactly. With tangents, it's kind of nice that, because your reference angle is pi over 6 down, so you're just adding pi over 6 to pi. You'll find that there will be a few shortcuts here and there for working with tangent stuff.
How did you know that tangent is also positive in the third?
What's negative divided by negative?
Positive?
That's why. Because in the third quadrant, you have your x and y values are both negative. Tangent's y over x, so it's negative y over negative x, which gives you
that makes
positive.
sense.
And that's the whole idea. Remember, all students take calculus. The enthusiasm of you guys is just it's beyond.
Thank you.
It's just, I can't even describe the feeling I get when I'm up here sensing this enthusiastic response that you give me. It's awesome. Oh no, I don't know what to do now because I am afraid. So this becomes fun. You have multiple trig functions in an equation.
Just divide by.
The sine of x times tangent squared of x equals the sine of x. If I divide by the sine of x, I eliminate a possibility, don't I? Can't do that. So what I need to do is I have to set this up as sort of a factoring style problem. Yes, we will factor with trig functions. It's great. So you get sine of x, tangent squared x minus sine of x is 0. What? Now think of this. Isn't this the same as saying that's kind of a bad way of writing it. Let me ask. These are two separate terms, correct? What do they have in common? Factor it out. There's a GCF. And when you have GCFs, you can factor them out. Now, do you have two terms that are both equal to 0? So now what happens is that you have two separate equations to solve for. It's a factoring problem where you have to factor out a GCF first, is really what this works out to be. So you wind up with, the solution to this is going to be where is sine of x equal to 0, and where is tangent squared of x minus 1 equal to 0. And we need to solve them both independently. So when you have sine of x equaling 0, that means what angle has a sine of 0? Which means you're going to look for quadrantals. Okay. So where is your y value? 0. It's at, yeah, 0 and 180 because it's 1, 0 at 0 and it's negative 1, 0 at 180. So my answer is here. If you draw it, here, and here. So it's at 0 and pi. You all right with that? If I go to the other one, you have, bless you, bless you. Third time's charm, bless you.
Thank you.
If you have tangent squared of x minus 1 is 0, what do you do first? You add the 1. So you have tangent squared. What do you do? You square root it, yeah. Bless you. So you have tangent squared, I'm sorry, tangent of x equals the square root of 1. Now if I take a square root of both sides of an equal sign, what happens? Plus or minus. So you get plus or minus square root of 1. Uh-huh. So now what angle has a tangent of plus or minus 1? Yes, you do. Where is tangent equal to 1? At 45. So tangent's equal to 1 at 45, pi over 4. Tangent's equal to 1 at 5 pi over 4. Tangent's equal to negative 1 at 3 pi over 4. And tangent's equal to negative 1 at 7 pi over 4. At every 45-degree angle within the circle, your tangent value is always either going to be 1 or negative 1. Oh, thank you. At all of your 45s of reference angles, your tangent value is always 1. So as you go all the way around, you're going to have 4 different angles that will give you this answer. Pi over 4, 3 pi, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Which means then that there are technically 6 solutions to this equation. It's not too much. All right? Yes, I said 6 solutions. Teacher years. But then again, my wife says something more. It's like when you hear that one kid swear in the back corner, like, how'd you hear me? Because I hear things. Is this about as goofy as things might get?
You mean like the next page is going to get even more goofy?
We'll get there. I don't know if I want to frighten you off completely yet.
Okay.
Because we still have to worry about inverses and stuff.
If you give us too much at once, everyone's just going to be like, agree that like no one knows how to do it. Just be like, yeah. Because if everyone agrees that no one knows what's going on in math, then
All right,
it
I
makes
did
everyone
not
feel
do-
better. So they're like, well, nobody else knows what's going on.
Okay, now, the instructions on these say to find the general solution. Just find it within 1 revolution, okay? So you're going to find it within 1 revolution. You can't do, don't, oh, you have to skip 21 because you don't know anything about a negative angle. I thought that was there. So we'll do that. We'll add one. All right. Do this as between 0. We'll explain what general solutions mean on Monday, as well as what you do when you have inverse trig function equations. We'll probably do this for the next 3 or 4 days, just so you guys know. Because I could progressively make these things more and more and more nasty.
Yeah.
Like actual factoring problems and things and stuff like that. Because it's fun.
John.
What's that?
But you're nice.
Oh, of course I am. Are you kidding me? There's some really awesome problems I get to do with this stuff. It's fun. We can do intersections of these things and everything. I mean, I have one here, it's cosine of x times the cosecant squared of x plus 3 cosine of x equals 7 cosine of x. Yeah! It's gonna be great.